Okay, so in the pre-lab we have this question that has 0.1 molar vinegar or acetic acid, and we have 100 milliliters of it, and we want to know how many grams is going to allow us to make a pH of 4. So there are two ways to solve this problem. One way is to use this pH and realize that that pH is the same as 1 times 10 to the negative fourth molar H+. So if I think about that, that means that I have my concentration of H+, and it also means that I have the concentration of the vinegar. So I can use those two things in the Ka and solve for the acetate. So what I'm doing is I'm saying Ka is equal to the H+ times the CH3COO minus and the CH3COOH. So then what I would get here is 1 times 10 to the negative fourth times x over 0.1 molar, and that equals the Ka. And if I do that, that's going to allow me to solve for the molarity of the CH3COO minus. And then I need to take that molarity, which is the same as moles per liter, and multiply by my 0.1 liters because it had 100 milliliters. And that's going to give me my moles of CH3COO minus. And then we need to use 1 mole of that for every 1 mole of NaCH3COO. And the last step is to take whatever the moles of NaCH3COO and go to grams. So 1 mole is equal to however many grams are in this from the periodic table, and I think the number was 82 grams or so. And you're going to get some number of grams here. We want to use 4 sig figs because even though this is 1 sig fig, we don't actually, I found out that we don't look at the molarities. Those are derived, and this is actually my measurement. So we want to have 4 sig figs here. An alternative to doing it this way is using the Henderson-Hasselbalch, which is what it says to do in the problem, and that would be pH equals the pKa plus the log of base over acid. Okay, so I know the pH was 4, and the pKa I think is 4.74, which is just the negative log of the Ka. And I know the log of, well, base is my unknown, and acid was 0.1. So we have some algebra here that you might not be familiar with, but it's pretty simple. All we do is, let's subtract here, so we get 0.74 equals the log of x over 0.1. And then what you can do is you can say 10 to the power of that and 10 to the power of that, so that when we rewrite it, I'm not sure what this number is, and I don't have my graphing calculator at home. So whatever that number is equals x over 0.1. Okay, and then you would solve for x. Or you could also rewrite this back up here, sorry guys, plus the log of x minus the log of 0.1. That's the other way that you can do log of one thing divided by log of another thing. And then you'll still use that 10 to the power of to get rid of the log. Okay, so many ways to solve it. Once we have x here, x is my molarity of CH3COO minus, and then we do all the same things that I showed you up here. Go moles to liters, moles, 1 mole for every 1 mole, and then to grams. Okay, I hope this helped. Thanks, guys.